Today I'll be showing you guys how to create this awesome setup where you can create any kind of designs you want, all with a few little splines. You'll see how we get the contours of things, have little gaps, and you can move around the statues and the area around them will update automatically. And not only that, if you take these splines and take even more of them and overlay them, you can get some really cool designs. Because as you can see, it always cuts out a little path wherever your splines overlap. And that's the thing, it only happens where it overlaps. So if I want to, I can just move this one a little bit over to the side, and you'll see it'll only do the little area here that is overlapping. It is not actually going and doing the entire thing. So I have full control over the areas, over the shapes, and all of this is possible thanks to PCG and PCGEx, the most extreme plugin there is. So let me show you how I do this thanks to PCGEx and some filters. To get started, of course, we're going to go to Edit Plugins, and then search up PCG, and make sure you have Procedural Content Generation Framework turned on, as well as the PCG Extended Toolkit enabled. And once you have both of them checked on, go ahead and restart your engine as needed. I'm going to work in this default landscape environment. For convenience, you don't have to. You can just make it use a simple spline. It is not an outright requirement. But to get started, we're going to need a couple of things. We're going to need a spline blueprint, and we're going to need, of course, the PCG graph that houses it. Let's start with creating the spline blueprint by right-clicking, going to Blueprint class, and selecting Actor. This is going to be our BP_foliage area, and we'll open it up. And here, all I'm going to do is add ourselves a regular spline component, and then I'll just drag this out a little bit so we have a nice little area here. In the detail panel, I will search for close to get ourselves a closed loop and turn that on. So this is fine for our little base spline. Compile, save it, and close it up. And then, of course, we'll need the PCG graph. So right-click, PCG graph, create an empty graph, and this is going to be our PCGEx_foliage area. So at this point, I can go ahead and just drag this out into the world already. It doesn't matter where I put it. It can be in the middle of anywhere, but now we have it out here and we can open it up. I'm going to be sampling the landscape, which means it doesn't have to be flat. So just keep that in mind. Doing with the landscape will allow you to have unnatural and uneven ground very easily. For something like flowers and foliage, it might be a good idea to use landscape there. So let's get started by getting the landscape information. Now right click and search for Get Landscape Data. That gets us all our landscape information. And from here, we can just use a surface sampler. If we just leave it by default and press D, you'll see there's our landscape being sampled just within the bounds of this volume. And again, it doesn't matter where we move this volume, it'll resample just that area there. You can see we can even move it up into the uneven area. It doesn't matter at all. But cool, we now have some points. But now what I really want to do is I want to just filter out points within a spline in the area. So I want to put my spline in the actual zone that we have here and only keep the points within the bounds of that spline and the volume. And thanks to PCGEx, that becomes quite simple. The only thing I'm going to do before I do that is I'm going to increase the size of the bounds here to make it just a bit bigger so we have a larger area to work with. This is just fine. And I'm also going to grab our spline, drag it out, let's place it somewhere around here and move these points around to get ourselves a more interesting shape. And let's say this spline is actually where I want to keep these points. So now let's go back to our PCG graph and make use of this information. So we're going to need the actual spline, of course. So I'm going to right click and search for Get Spline Data. In the detail panel, I'm going to change the actor filter to all world actors. Instead of by tag, we're going to go by class. And the class is going to be what we created, which is BP foliage area. We'll go ahead and select it. And I want to turn on select multiple. So it selects multiple in the area. And that's all we need here. But how do we now use this? Normally you would need to use intersection node, but we're using filters in PCGEx, which are a lot more powerful. Now, how do you use filters in PCGEx? All you do is right click, search filter, and you'll see there's a lot of the default filters, and then there's a ton of PCGEx filters. My goodness, there's tons of them. I'm not going to go over every single one, but I will show you how to use them. And the thing we actually need here is Uber filter. If you select that, that is actually the node that we're going to be using to filter with. As you can see, it takes an input of a filter, so we can use this as a filter node, which is kind of similar to the default attribute filter, except this one is considerably more powerful, and you can put in multiple things into the filters at the same time. So we'll be using this. So in this Uber filter, we're going to plug that all the way through. And now how do we plug this through? Because this is not actually an attribute. This is a spline. We need to know what we're doing with a spline. How are we sampling it? Well, we need to use one of the new filter nodes with PCGEx, and this is filter inclusion. If I go ahead and select it, you'll see it has a target as an input, which is a wildcard. So we can actually plug in our spline into here. We can plug the filter into the filter, and then we can control how this works. Now, if I try debugging this inside by just using a simple debug node, you might notice there's not anything in the world here. It doesn't seem like there's a single point, but in fact there is. And for some reason, this is a bug with PCG in general. If after the surface sampler, I just use a bounds modifier, which is just set to the default of scaling the point by 1 and 1 in all axes, and have that plugged in right before, there's all our points properly being displayed. For some reason, the extents of it get broken visually here, but now we see them all. And if you're wondering why I haven't told you guys about this before, it's because I just learned about this myself. If you're having trouble seeing the points sometimes depending on certain nodes, you might just need to add just a bounds modifier set to the default values, and somehow that fixes it. Hopefully that's going to be a fix in the future, but for now, nice and easy fix. But the main thing already you could see here is we're now filtering basically only the points inside of this area. Because we have the spline, it is set to is inside by default, and we're checking if this is true. Go ahead and debug this. On this is inside node, we can change a few things, like the check type is inside, or we can do is outside. So we can actually just use this as effectively a difference node to select everything outside of this area. You can also choose is on, and if you do is on the spline, then you need to give it a tolerance, let's say 200, and now it is selecting all the points on the line within 200 units away from it. We can increase this a little higher, and now it is selecting all the points within 500 units that are touching the spline. So you can already probably see how much more powerful this is just right off the bat than just using a regular filter or intersection node or difference node. You already have a ton of control. For now though, we're just going to go on the interior part. So I'll swap this to is inside, and I'll reset the tolerance back down. And by the way, if I want to, I can use multiple here. I just duplicate this around and get another one. And you can see it will just completely overlap the two. I don't have to just use one, but it will always just filter them out within the bounds of my area. For us though, we're happy with this setup here. So now that we have the bounds, I want to select just a little bit inwards from the border and create a nice ring. Well, to do that, we're just going to go off of this inside and use another Uber filter to filter out from here. And in this case, we're going to use another inclusion. What we're going to be including here is not based on the spline, because I want to show you that this method does not require you to have a spline. It could be any shape from anywhere in any method. As long as you have points, that's all you need. Because what we're going to be using is a pre-made subgraph that gets what we want. So I'm going to right click and search for concave hull. You'll see PCGEx concave hull 2D. I can go ahead and select it. And the way this works is we need to plug in the points we want to use into this points input, in this case from the inside filter. And this hulls goes into this is inside, and this goes into our filters. Again, I will set up a debug here for the inside, and already you could probably see a little bit away from the edge, we're starting to not have these points. If I turn on the other debug, you could see this is the points that we're missing out on. They're cutting out already. But we want to change this inside filter a little bit. In my case, I want to change this is inside check to have a tolerance of 500. And now you can see we've now cut out quite a good area from the inside. And here's the thing, we've cut out inwards like this, but that's because I'm checking the inside filter. If I check the outside filter, we're now left with a contour of this entire area on the inside. So I can actually spawn things just on the outside now if I'd like. Now it's almost configured correctly for this is inside, but really we don't want is inside, we just want on. I want it to be on the line of a tolerance of 500, because this will make it so the inside area here is this section, is the border, because that's really what I'm actually filtering out. Because as you saw before, is on will allow us to actually set this up to be on the line, and because we're already filtering on the inside, we're now just left with the boundary here. So if I want to now, I can now spawn some flowers on the contour of this entire thing. So let's do that. I'm going to turn off this debug, and then from this inside, I'm going to drag out, use a transform points node just to give it a little bit of variation. I'm going to scale it between 0.7 and let's say 1.5. I'm going to rotate it randomly 360 degrees, and then I'll use a basic static mesh spawner, and I'll add some mesh entries to here. And once I do that, you will see we have some flowers on the outside. The one thing I'm noticing immediately is there's not enough of them. It's a little bit too sparse for me. So let's go back earlier on to the surface sampler. In the points per squared meter, instead of 0.1, I'm going to 4x it to 0.4. And now you'll see we have substantially more flowers here. So just like that, we already have a nice border. So that's great. And from here, if we so wish, we can take a look at what is remaining, which is the outside of this area, which is all the points on the inside of here. So now we can work with this. And guess what? We're going to filter it one more time because I want to now have a gap between the outer section and the inner inner one because I want it to be kind of like a guaranteed walkway next to the flowers on the inside. So we're kind of going to need the same thing here. So I can take all of this, duplicate it down here. From this outside, we can plug this all the way through, except now instead of is on, we want is not on. And we'll keep the values the same. And when you take a look at the debug, you will see we now have this path right next to it that the points are now being cut off. Because we're still using concave hole 2D, we're able to cut out a little more based off of the new shape that we had, which is why we're not using the splines information. We're using it based off the points that are already existing here. So fantastic. We've now filtered it a little bit inwards. So if I so wish, I can already spawn the other flowers on the inside and we're guaranteed a nice design here. But instead, you might recall I spawned some statues, and around the statues there was first nothing around, then a ring of those outer flowers, and then again a ring of nothing. So again, to be able to kind of walk around the area if you so wish. It looks a little nice aesthetically for me, so that's what I went with. To do that, we just need some kind of actor in the world that's going to be our place where we spawn the statues and everything from. I'm just going to use a default target actor, but you can absolutely have a custom blueprint that you can move around or whatever you'd like. So in my case, I'm going to add a simple target point. It's going to be just right there in the middle. I can move it around wherever I'd like. It's a little hard to see, but don't worry. That is fine. We'll have one here for now. And now we can filter the points with the target point. By using a simple right-click get actor data, we can get the information of the target points. So like before, we're going to change it to all world actors. Instead of by tag, we go by class, and the class is a target point. Again, make sure select multiple is enabled. And if you'd like, you can absolutely go by tag. If you want to use a custom blueprint, object, or tag, you have complete leeway here. And lastly, on the get actor data, instead of parse actor components, we want to get single point and turn on merge simple data. But now what I want to do is only keep the points that are a certain distance away around my statue. As you might have guessed, we're going to be using another filter. Plug that all the way through. But this time, we're no longer using this inclusion filter. We're not using concave. We're doing a different thing, which is we're going to be using a distance filter. Now, there's distance spatial by default, but what we want is the filter distance from PCGEx. This also takes a target, and this we can put into filters. And if I go ahead and duplicate the debug here and enable it, the hotkey for this is E if you need it. E toggles disabled and enabled state. We will see everything is gone. Every single point. Now, why is every single point gone? Well, it's because we haven't configured the distance. It says basically around 0 with a tolerance of 0.01. And you can take a look at the different values here. Is the distance equal, not equal, greater, less than? All the options. You even have nearly equal and not nearly equal. And the cool thing about this nearly equal and not nearly equal is we go with this just regular nearly equal version. We can say, is it nearly 1500 units away and within a tolerance of 500? For this to be true, the object has to be not only 1500 points away, but you know what? We can go up and down 500 points. So really, we're taking a range from 1000 to 2000 distance away any of these points. And when you do that, you get a donut. We now are filtering on the inside and outside. And if I duplicate the point and put it somewhere else, you'll see we'll get more of these. So now we're filtering just those points, which means we no longer need to debug this. Instead, we can move these transform points all the way over and then plug this inside into the transform points. And you'll see now we have the same flowers on the border as we have, and these can go ahead and overlap each other, as you can see, but they will never actually create an area where they completely overlap because it's still within that range here. It is being cut out. Now, the really cool thing about filters is you can stack them. So if I look at these points and I'm thinking, you know what, maybe there's too many, I can go ahead and filter them if I want. And we can do that by just right clicking and search for filter random. And there's the filter random we can grab from PCGEx. And this is just like a point filter to select the amount of points you want. Here's the threshold. If I just plug that into filters with the other one, you'll see we're only keeping 50% of the points randomly. So it's very powerful. We can just prune out a little bit. In my case, I don't want to do 0.5. I only want to prune out, let's say 20%. So there's just a little bit fewer of them out here. So just like that, we have this kind of system here. Fantastic. But now we have that, we can put the statues in the middle. And statues in the middle is quite simple, honestly, because we're just going to use the target points themselves. From here, I'm going to use a transform points node, and I'm going to scale these statues up 50 times because I know in my case, they're absolutely tiny. And then I'm going to use again, static mesh spawner, a regular one. I'm going to add the mesh entry, and there it is. So now we have our statues in here. Because they're using the target points, I can just rotate the target point and it will rotate the statue accordingly because we're just using the rotation rotation of the target point, so we can now control how this rotates and how this faces on every single one of these. So now let's do the actual rest of it. And again, I want a gap between these flowers and the rest. So for these remaining outside points, we can take a look at them by debugging them one more time. Our remaining points are everything on the inside here, including the area where these actual flowers are spawned, and of course the rest of the stuff here. Because we've randomized, we are now skipping a few of these points, which is why you're seeing a point here and there. Foliage would have spawned before, but now we've cut out 20%, so we're getting a few points here. So we're going to grab another Uber filter. It's going to go from the outside, and we're going to use a distance node again, but this time we're going to distance it a little bit further. I'm going to add another distance node. I'm just going to duplicate the one from before and use that and plug that into our filters. The difference is on this one, I want to make it greater than 3,000 units away. Why 3,000? Because using this filter, our foliage is anywhere from 1,000 to 2,000, and I want a 1,000 gap in between. So if it's greater than 3,000, that is fine. And again, if I debug the inside now, you will see we're now cutting out quite a bit of area. So you can see we're still maintaining the border on the outside. We now have the gap from these points of 3,000 units in a radius, and we're left with the rest. And just like before, we can combine this with other filters, and there's a lot of them. You can compare it with the angle, the bounds. You can compare it with a actual numeric number or a string. You have dot comparison, distances which we'd be using, inclusion which we'd be using. So I'm only scratching the surface of filters, but know that one, they stack, and two, they're incredibly easy to use. But now that we have this filter, let's go ahead and finish this up. I'm going to use a transform points here from the interior, and these other flowers I'm going to scale between 1 and 3 because they're a bit small. I'm also going to rotate them randomly 360 degrees. Like the other times, I'm going to use a regular static mesh spawner and populate them in. I've just put in 5 different variations here, and now we can see we now have these very pretty flowers everywhere else. It's not quite pretty with this landscape, so I'm just going to select it and replace the landscape material here with just a basic mega scans one to give it a nicer visual. But you can see now we already have a pretty cool result. But this is not where it ends, because this can become so much more powerful. Because in our case, if I go ahead and take this spline and let's say I'll cut it in a little bit and make it a little bit smaller. Let's say we have this area. I can duplicate this entire section and put it together, and it will combine them in the 2 areas, and of course cut out where it needs to. So you can have one big combined section. But what if you wanted to have kind of what I showed earlier on? Maybe you don't want to have these combined. Maybe you want to have more unique shapes. Well, if we go back to the kind of the beginning where we got the spline data and we filtered it out for the inside, this inclusion has a really cool option. Minimum and maximum inclusion count. What does this mean? Well, if I turn on min inclusion count and we can leave it at 2, you can see we just have a strip here. Now what happened? Well, that is the area where it overlaps between the 2 shapes. So now what we can do is have one of them be kind of the overall area within our actual bounds that we want to potentially have something, and maybe that is the full thing. And then with all future ones, we can go ahead and just add little areas within that. And because it's the only time where it kind of overlaps the 2, you can see we're now cutting out between the 2. That might be a little hard to see, so I'm going to change the color of this spline, which is kind of our main one on the outside. I'm going to change the unselected color here to, let's say, green. And you can see it is now overlapping at least 2 in this area. It's overlapping this spline and it's overlapping the green one. And if I go ahead and duplicate this and put it right in between here, you'll see we can now get this combined here as well, because it's again overlapping at least 2. And you can increase this even further. You can change this to 3, and you'll see because these 2 areas are now overlapping at least 3 of these splines, it is appearing. In our case, we'll keep it at 2. Now it's really cool that it's combining here, but as you recall in my example before, I wasn't combining. I actually was cutting out pathways using these splines. And again, in this is inside node with min inclusion count selected. If we change this tolerance from 1 to, let's say, 500, we now get a cutout of 500 here. And so now the only time we get these points is within a 500 bounds of that area. To make it a little bit easier to see, I'm going to go ahead and just make this area a bit bigger here. And you can see we're still getting the cutout from the actual statues that still has the gap and the distance here as before. It'll be much more easily visible if I just go ahead and turn on this debug for seeing what we are keeping from this very beginning. And you'll see we're keeping just these points because we're filtering out a tolerance of distance here, basically on this point, to be a little bit inside. Before, this inside was pretty much getting everything on the inside, but now we're giving it a tolerance So we're kind of cutting in from the edge. And you kind of see the same thing here. It is now cutting in from the edge. If I change that value back to 1 where it was, you will see all of these shapes get pushed out right up to the edge of the spline. But because we're pushing in slightly, we can do a little bit less. Let's say 250 here. And you'll see again, it is 250 points away from the edge, which is how we're going to get these shapes. And we go 500. And now we're guaranteed paths wherever we want, which becomes really cool because we can now just have another spline intersect here or do whatever we'd like to kind of get really interesting and cool results by just adjusting the splines however we wish. And by messing a little bit with the curves, you can see you can get really interesting and cool designs relatively easy with pretty much guaranteed paths kind of around here. You can of course go as far as cutting out little areas here for yourself using other filters or exclusion areas, because you can just make little entrances by just putting another object there and then maybe using another distance node to just cut out around it so you know there's not going to be any flowers kind of right there. But this graph is relatively simple, and really all it's using is the filter node, some distance checks, combining them for a little bit of variation, and we're getting the concave kind of interiors with it. And using just a combination of a few of these, you can get some really cool results. So hopefully this is getting your head thinking about the possibilities of using the filters with PCGEx and putting them into some of your projects, because let me tell you, it really does simplify a lot of stuff with the regular PCG using these filters. And I've just scratched the surface. I've only showed you a couple of them, but there's a ton, so try them out. Now, as always, the project file for this will be available on my Patreon if you want to play around with it for yourself. And I want to give a big thank you to the Patreons that support the things that I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is down in the description below. And a big thank you to Tim, the creator of PCGEx, for creating an awesome plugin and helping me learn it so I can teach you guys much better. But if you're looking for more PCGEx tutorials, check out this one right over here. That's really going to help you out getting started with PCGEx.